Today we are going to discuss a little bit about building desktop application using Electron. This talk is not related to Java, not even a bit. It's more the Electron framework and how we used it inside of Skype and Microsoft. My name is Catalin. I am based in Prague, working for Skype for the past 4.5 years, and I am native Romanian, so not Czech. Okay, so here is the roadmap. We will discuss a little bit about what is Electron in general. We will go through some small examples of an Electron app. Then we will discuss what are the features of Electron, the Electron API itself, what it offers to you to build your own apps, and what you can do in case you have a missing functionality. Then, of course, when it comes to desktop apps, we need to care about security, and that's quite important. Then we will discuss about the communication between Microsoft and Electron, how we used it, what we learned from it, and all the collaboration there. We will touch base on what's the future of Electron, based on communications with GitHub and their plans going forward. And we will discuss a little bit about the pros and cons. So, first thing, what is Electron? You might think is something related to chemistry. Well, it's actually right, because how Electron came to be, it came to be as the atom shell, which is the shell used by the atom editor that was developed by GitHub. So it has a very fancy name, very fancy graphic there. As I said, in 2013, it was named Atom Shell. It is a framework and a runtime. And in 2015, it actually split from the Atom Shell, so that's why they call it Electron. And it offers you the possibility to write desktop applications in JavaScript, HTML, CSS. And if you are like very interested in native code, you can also do C, C++, and Objective-C. You can see here the main contributors in the GitHub community. Of course, the owner is GitHub, but then you have Microsoft, Slack, which for sure many of you have heard about. The other one is Figma. It's a tool for designers. It's a very cool tool, actually. I recommend you to use it. And there's Brave. Brave is a browser based on Electron. And they're also very highly into contributing back to the Electron source code. Yeah, you might be thinking, what is this guy talking about? Why web applications for desktop, right? Like, why not go to native code? So probably a lot of you have these faces right now. Don't exactly know what the talk is about, but let me tell you something about what desktop applications offer different than web applications. So you have access to the peripherals, to other devices, you can interact with cameras, microphones, and so on, which, for example, for Slack and Skype is very important. Then you work with files, which you cannot do from a browser, because the browser itself is contained, it's secured, and it doesn't have access to your system fully. Then you have notifications, because you have the Chromium API to do notifications if you know about it. But it's not able to do the rich notifications that people want to do, like replying to messages, having embedded something else there. Then you have the possibility of shipping an app to App Store, like to the Microsoft Marketplace or to the Ubuntu Marketplace and many other places where you can have these apps. Also on Windows, you can do that, as I said, in the marketplace under a UWP app. So you can bundle your Electron app as a Sentinel app and publish it there. And it's, the desktop apps are available for Windows, Mac, Linux. I included here also cool ARM64 and MIPSL 64. They're quite used in Raspberry Pis. They're used a lot in China, for example. The MIPSL is it's crazy out there in China, and we are working on releasing Electron there. The components, a little bit of how Electron is structured. You have two main components, Chromium and Node.js. You might get scared when you hear about Chromium, but it's, as everyone knows, it's the open source browser from Google. It uses V8 as the interpreter for JavaScript. It uses Blink for the layout engine, and these things are always up to date. They give you new features. But Electron only uses a subset of whole Chromium, which is called codename libcc. It comes from lib Chromium content, and it includes only the Chromium content API. Then there's Node.js. Everyone knows about Node.js, open source JavaScript framework, and then runtime, and then uses also V8 because you have JavaScript code that needs to be interpreted, and then it's, as everyone likes it, it's event-driven, non-blocking I/O, and you have the goodies of NPM, right, the package manager. And how is this like linked together? Because it might seem like, okay, Chromium has its own V8, Node.js has its own V8. The thing is, what we do in Electron, we actually override the Node.js V8 with the Chromium one. So in this way, you basically can communicate between Chromium and Node.js processes easy using the built-in functionalities. As like a slim architecture overview, you can decompose Electron in two major processes. So the first one is the main or browser process. Main is what we call it in the Electron world. Browser process is what Chromium actually calls it. Then you have multitude of renderer process. Well, actually, the renderer process is actually the UI. When you see the native window, that's basically a renderer process. And you can have a multitude of them. And communication between main and renderer, because you will need communication to do system-related stuff, is done through IPC, which is inter-process communication. And based on the diagrams here, you can see in the main process, you have access to Node.js APIs. So you can use, for example, file system APIs. You can create, delete, and many other NPM packages that you can think about. You can use them there. Then you have the Electron APIs, which we will touch base a little bit later. And then we have the renderer process. In the renderer process, you can have Node.js APIs, but I highly recommend not to, because imagine if you're having a remote content loaded there and someone actually manages to have access to your file system. So try every time to, I will talk about that also in the security slide. It's a big emphasis here. Then you have the Chromium API. For example, you can access IndexedDB local storage and many other things that Chromium offers. And again, the Electron API. The Electron API in the renderer has something shared with the main one, but it also has some specific things. So let's look at the first Electron app. I have some slide with the code, but I can show you directly on Visual Studio Code, which is cool because it's actually an Electron app. It's one of the biggest Electron open source apps. After Atom, it was the second app that was released to the public. It's made in Microsoft and it's totally open source. So here you can check the main components actually of an Electron app. So you have the package.json, because it looks like a Node application, right? So in the package.json, you have details about the app, some scripts that you might run in order to start actually the application, right? Then you need a main.js, which you can see here. It's specified as main, and this is translated into the Electron world. This is associated with my main process, what we were talking in the architecture. So if you check here, in the main.js, you have all the logic that is run in the main browser process. So you require, for example, app and browser window from Electron. App is the one that takes care of the lifetime. The browser window is the one that actually starts the UI. And then you require path and URL because you want to load the index.html, which is well, you need an HTML, right, to paint something on the renderer. So here we have a create window, which creates the browser window, so it pops out the native one. It loads the URL, which is the index.html you can see here. I will show you the contents of the XML. The HTML is very simple. And then basically the main window, when it's closed, enlarge the font, yeah, sure. Maybe this is, yeah. So this is emitted when the window is closed, so you can take care of what happens to the window. You might not only dereference variable there. You can do a lot of other things. And as I told you, app is the lifecycle manager, basically. So when you have a ready event emitted by Chromium, then you create this window. Because some APIs actually are not available until you actually get this ready state. And then you can also do something when like window all closed, you can quit the process. You can see here, it's only treated if it's not on macOS, because on macOS this is handled by the system itself. So this is like just in like very simple app. The HTML, it's literally simple. It just prints out what Chromium, Node.js, and Electron version you have bundled. And you can also include script here. And as we discussed about the renderer process, this is actually running the renderer process. So for me, right now, the renderer process doesn't have anything, but you can add there whatever you want. So in order to actually run the application, you need to do npm install, but I already installed that because that takes like some time to download all the dependencies. So then I can do just npm start, and that will start my Electron application. And this is like the hello world that it says just we are using the Node.js version and it uses the latest beta Electron available on GitHub. Okay, but we discussed also the IPC, right? What happens to the inter-process communication. So let's see the same example in which we are trying to do some hello world from main to renderer and back. And you have two things to do here, sync and async, of course. So I'm not going to touch discussing about the code that we already discussed. We can skip directly to the IPC main. So you have this API in Electron, which is called IPC main, and it is used for communication for the renderer. And you can see here that on hello async, it actually sends back echo message, and when it gets hello sync, it overrides the event return value to hello main async, because async and async work differently, right? Then, finally, we have in renderer.js, we actually have some code. And here we treat the opposite, right? We have IPC renderer, which is the API from Electron for the IPC communication in the renderer, and we do the same logic there. So what else have changed here, because this is actually printing to the console, I didn't want to touch the HTML, I'm opening also DevTools when the application is ready. So this actually opens the DevTools because it's a Chromium in the end application, so you have full access to the DevTools. So let's see what happens. The same thing, npm start, and it will launch the Electron application. It does Electron basically dot, so it loads all the HTML and JavaScript from there. And after the ready event, you will see here, you can see two things, right? You see the hello renderer sync here, hello renderer async, so this is what the main gets, because main is the one that runs in the console, right? But renderer is the one that runs there, so you see it in the console log, the responses from actually the main process. So that's in like a small example of actually Electron can do. I have it also here, like what are the main components that you need for the first time. This you can look after the talk, and then the communication, and this is the result with the communication enabled. So now, let's talk a little bit about the Electron API, because it offers a lot of functionalities. So in the main process, you have the app. We touched based on that. It's the Lifecycle Manager, so you know what to do when the app closes, when it's ready, and so on. You have an auto updater, because in desktop applications, you like your applications to be up to date, right? As you are deploying them to the web. So this is actually supported only on Mac and Windows, and it uses the Squirrel framework underneath. In Mac, you have that already bundled in. In Windows, there's a fork maintained on GitHub of the Squirrel for Windows. Then you have Dialog. Dialog is actually for enabling file transfers, for example. So to just pop up the native file search box in Windows or Mac, the Finder, and then you also have like native messages. For example, something has happened, click OK, or things like this. IPC main, we talked about it, the inter-process communication from main to renderer. You have power monitor. This power monitor does exactly what it says. It's basically detects if your laptop is plugged in or not, and you can do some logic around that. You have the tray, so because it's a desktop application, you want to set some icons, you want to set some menus to your app, so this is very useful. Then it also supports the touch bar API. This is only for Mac. I'm not aware right now of anyone using it out there in the wild, like in the Electron apps. It's still like in alpha mode because it's a little bit cumbersome to use as you need to access it from the renderer in the main. So it's a little bit complicated, but it's cool to have it still there. In the render process, like the main parts of it are the IPC renderer. We talked about that. The remote. Remote is actually a cool thing that you can actually access objects that are exposed by main process. So, for example, the touch bar API, as we talked, you can actually require the remote of Electron touch bar and use it in the renderer directly. Then you have the web frame, which gets like details about can set, for example, 200% zoom factor. We have also some shared APIs, so they're available in both main and renderer. You have clipboard, copy and paste, of course, crash reporter. This is cool because in the web, if your app crashes or something, it might be the application itself, the Chromium or the browser, but here you can actually have access to the JavaScript crashes, to the native crashes, and it uses the crashpad, if you're aware of Chromium, does a crashpad model. And we are using actually internally Hockey app, which supports this crashpad server because the crash reporter needs a remote server to send these crashes to. You have native image. Native image is actually creating PNGs and JPEGs, and you can use them as attaching to the tray icon or other things. Process is actually a fork of what Node.js process does, so it gives you information about the process and what Electron adds functionalities to it, for example, to know what Chromium version it runs and what Electron it runs. Then you have the screen, of course, width, length of the screen, max size, and all these things in order to fit your application on different screens. And you have the shell, which is like actually access to the URL and file handler natively. So if you have a URL internally, it can open the external application for you, which is a cool feature. There's a lot of knowledge out there. The main point of entry is the docs on Electron side. Then I highly recommend Felix's book. Felix is working actually on the Slack desktop client, which is also built on Electron, and he has a very nice introduction about Electron. There's Electron Userland, where you can find a lot of cool tools that you can use in your Electron apps, like packaging, or building, and all these things. And there's also a Pluralsight course, and probably also some Coursera courses, if you're interested. So, now, you saw there are a lot of APIs, right? But maybe you're missing something that the Electron team doesn't have implemented or cannot implement in the framework because it breaks some guidelines, let's say. So you can go native. As I talked, you can go and write your own C, C++, Objective-C, native node modules that you can run on Linux, Mac, Windows. And how can you integrate this? There are like 3 separate steps. You can use NPM and setting some environment variables. Like, for example, you want to build on a 32 or a 64-bit architectures and other things. But then there's a cool tool called Electron Rebuild that takes care of this all by itself. So you don't need to care about a lot of these things. Or if you're a hardcore developer, you can go and use NodeGIP and directly define what you want there to be built, debug symbols, and all these things. Troubleshooting. Why I included troubleshooting here? Because there are a lot of problems with the native mono modules. For example, we had issues when we were building 64-bit Electron that included Node.js 64, but we had a 32-bit binary of a native node module. And that basically the Electron app doesn't start anymore. So you can have this 32 versus 64, and it's also caused by the V8 headers compatibility. Because with each V8 increment, the APIs change, so you need to cross-compile it against the newer ones. But what I like on GitHub is they say, when in doubt, just use Electron rebuild, because it does all these things for you and you don't need to care about all this mess. So I included here just like Guitar, SQLite 3, spell checker. These are some common native node modules developed by the folks in GitHub, Slack. For example, Guitar uses the keychain functionality of your system, so you can store passwords, the identity that you have. If you have, like, for example, Skype or Slack, you can store there the credentials safely. SQLite is the database, of course. If you don't want to use IndexedDB from Chromium, you can for sure use SQLite 3. Then the spell checker is actually built by the folks from Slack, and it's very useful if you have a chat application. And there are many, many more out there that you can use, or you can go custom and just create whatever you think about it. So security. I think I needed a way bigger image here because there have been ongoing discussions about the security of Electron apps. My main key here is change your mindset. Electron is not a browser. Even though you think it's a browser because it's based on Chromium and Node.js, it's not a browser, because the code actually wields a lot of power. You have access to the full system if you allow Node.js to run in the renderer process, which doesn't happen in a browser, right? Try at least to not include third parties. Try to include things that you trust, first parties, and every time actually bundle your JavaScript HTML with the application. And always be on the latest Electron. This is important. Even if it has issues, the folks from Electron are very helpful and on fixing crashes and all these things. What it offers to you is a new Chromium and a new Node.js almost every time, and those have a lot of security patches, a lot of remote content exploits that were fixed already. Then there's a whole bunch of checklists on Electron documentation, which I encourage you to go if you want to create your own Electron app. Only display secure content, never load HTTP content. Disable the node integration, as I was talking, in the renderer because of the remote content that you can enable. Then you have context isolation. This allows the processes to be context isolated. So basically, you won't be able to share memory between them and all these things, so you have a safe environment. Do not disable web security. Web security is a standard, and you should have it on. Always use CSP. If you don't know what CSP is, Content Security Policy, it allows you to define where you can load CSS, where you can load JavaScript from, and a lot of other cool things. Override and disable eval. I don't think I need to talk a lot about this. This is a known issue in the JavaScript world, and there are many, many others on that list. So, Microsoft and Electron, right? What have you done together? Yeah, this might create some smiles in the audience, but Microsoft actually loves open source. Hassan can tell you that. He's in the Microsoft booth. We are one of the biggest contributors right now in GitHub, and you can check this out just by going to the GitHub Microsoft place, and you have this nice, cool, their title, Open Source from Microsoft with Love. So, this journey with us, with Electron, started 1 year ago, and we were participating to Electron mini summits. These are like gatherings of the main stakeholders, let's say, of Electron, and discussing about road plans and all these things. We had one in San Francisco in 2017. We have one co-hosted in Tokyo, the Microsoft office, and we are going to co-host another one in Prague in this year in June. You can find more information about it on the GitHub site. Then we had a core summit where we discussed actually the ins and outs of Electron, because Electron is quite a huge beast, and to be honest, no one actually knows the whole mapping of the code. So that was a good gathering, and then we also helped each other with security issues. Here you can see the main apps in Microsoft: Skype, Visual Studio Code, and Microsoft Teams, which Microsoft Teams is the collaboration tool from Microsoft, available on the Office 365 subscription. Then we did more things. We contributed back. We are in charge, basically, of the Chromium upgrades, because we care about security, and Chromium fixes security with every major bump that they have. They don't disclose it very fast, but we need to act fast in order to get the latest Chromiums inside. We helped with the build infrastructure, the scripts that they have, how they're linking together, because at the beginning it was a little bit problematic, let's say. Then we implemented native notifications on Windows 7, which weren't supported at all. You didn't have, if you deployed your application on Windows 7, you didn't have notifications. We did a lot of security patches. And then we also, this Chromium dcheck is like more like a geeky thing because, but it's also very helpful because the debug mode of Chromium has dchecks. These are like checking, asserting if you're doing the correct API calls from, let's say, different threads. And we found out a lot of problems there that actually managed to fix Electron crashes. So what did we learn? We learned how to optimize and profile web apps. Because Chromium comes with a cost. It comes with a memory cost. Every renderer has a memory footprint. And if you trust your JavaScript, don't. Try to optimize it as much as you can. Actually, Electron offers profilers. You have Node.js profiler. You have Chromium built-in profilers like you can actually use from the dev tools. You can attach debuggers directly to it. So there's a lot of things that you can find and use to optimize this. We grew our skill set because we use JavaScript, we use TypeScript, we used HTML, CSS, C++, Python for the scripts, and a lot of other things. And it's a cool thing. It's a cool thing to be a part of an open source project because you learn a lot of things. Then we learned the pain of upgrading to newer electrons, and by this I mean we learned the pain of actually doing the Chromium upgrades. These are very hard because Electron is tightly coupled to the Chromium APIs, and the Chromium APIs change very fast between releases. And then the Electron community is a very nice place to be. The folks there are very open-minded. We have discussions every week. We are attending plannings together. We have one-on-ones with them. It's a nice place to be, actually. So let's talk a little bit about the future of Electron. What's in store for it in the near future. So there's going to be Electron 2.0 coming out quite soon. It will have some breaking changes APIs. It will disable by default for you the Node.js integration in the render, which we were talking in the security. It will be shipping with a newer Chromium, and afterwards there will be different ways of treating actually the versioning scheme that we currently have in Electron. You can read about this on the GitHub issues that are hosted there. Then there will be focused on security, about this node integration disabled and many other patches that are not yet exposed. We are talking about modularity of Electron because Electron bundles a lot of things. For example, as I said, Chromium Content API is a subset of Chromium, but it actually contains some stuff that people don't want to use. Like, for example, not everyone uses WebRTC, not everyone uses PDF Viewer, not everyone uses a lot of other things. And we are thinking about offering this modularity. Then we want to focus on faster releases of Chromium because Chromium releases every 6 weeks, has a cadence of 6 weeks releases for major versions, but Electron has a slower pace because of the integration it needs to do. And then there are the GitHub issues, which are growing quite a lot, and we are trying to figure out what's the best way to treat them. We can find there like a lot of crashes, but there are also people that are just asking about their apps, and they're like a lot of issues, but they're not that critical. So yeah, you saw what Electron can do, so let's discuss a little bit about the pros and cons. There are as many pros as many cons there are there. So let's start with the cons. So the size of an application. The size usually goes over hundreds of megabytes because you bundled inside the Node DLL, you bundle a lot of libraries that you link your application to. Then HTML, JavaScript, CSS, because not everyone likes it, of course. It's not a standard for developing desktop applications. If you go to Microsoft, if you go to Linux, if you go to Apple, no one is going to tell you, go first and use Electron to develop your apps. They are going to offer you their native functionalities. For example, on Windows 10, you have the UWP apps and so on. So, and then you have dependencies of Node.js and Chromium, and that means security holes, because Node.js and Chromium has dependencies on third parties. And these third parties are like libuv, which, if you know the library Unicorn Velociraptor, yeah, that's the name of it. And it's used for communication purposes in native code. And that has a lot of security issues that are coming out with each version bump. And many other things like OpenSSL, and I'm not going to touch based on the multitude of dependencies we actually have. Multiprocess equals higher memory footprint because every renderer process is a Chromium UI, right? So, and it has a memory footprint even when just created. So you need to take care of this by optimizing your application more, but by default, if you create like 100 views, then yeah, you will have issues. Pros, there are a lot of pros also. You have a vibrant community, that means you can go there, ask for stuff to be done. People are very open to everything that the feedback and all these things. It's one source code for all platforms. This might be important for a lot of people because maybe you don't want to have like separate builds for Linux, Mac, Windows, and then mobile. What we actually do is we use in the Skype client, we use React and Electron. And with using React, you actually can go the React native way, and you can have iOS and Android sharing actually the same code that is shared on the web and desktop. Then you have HTML, CSS, JavaScript, because things are easier to do sometimes there. You have developer tools, so you can debug very fast your application. You can see how it looks and all these things. You can make use of the latest features, and when I'm talking about the latest features, I'm talking about the latest features from the Blink layout or the V8 engine, which, imagine you're doing a web application and you need to write different code for, let's say, Firefox, Safari, Edge, IE, maybe not, and so on. So this offers you like to focus just on Chromium and ship the application everywhere like that. So, and you have also a multitude of native node modules. So you can, if you miss something, you can go ahead and just do something about it, install an npm package, and load it in your application. So I want to thank you, but it's not yet over. So I want also to talk a little bit about our new Skype client. So it's built on React and on top of Electron, and we are shipping it to Windows 7, 8, 8.1, 10, Threshold 1 and 2. Don't blame me for the naming. We love naming in Microsoft. These are the Threshold 1 and 2 are basically pre-versions of the Microsoft Marketplace. So you don't have the UWP app there. And then we support macOS 10.9 higher, and Linux, a bunch of distributions there. So that gets me to another thing, that Microsoft actually loves Linux. And this is actually took from a slide that Satya had at the Build conference, where he introduced the integration of Linux subsystem inside of Windows 10. And why I'm saying that Microsoft loves also Linux in the term of Electron is that we have had a Linux app since a long time, but it was never maintained. So what we did, what my team actually did, we shipped the first version of the Electron Skype for Linux beta 2 years ago, and nowadays it's actually built as the same one as the Windows and Mac. And last week, on 1st of February, one of my teammates actually went to Redmond Canonical Conference, where we announced the new way of bundling applications for Ubuntu, which is called Snapcraft. I highly encourage you to go there and check it out. They want to make it a standard, and they need as many apps there in order for people to see how easy it is to install it. So what this does, it actually, you don't need anymore a deb package or an RPM package and all these things. So it offers you a unified way of shipping your apps. And actually, it's going to be supported in other distros, not only on Ubuntu. So please give a try to our new Skype and give us feedback. We're happy to hear from you. And that was it from me. So questions now.
Hi.
Hey.
So you mentioned that you have your renderer process,
Yes.
which runs on a single thread, and then the main on a different thread. So do you still support then all of the from my renderer process? Can I fire a web worker thread?
Yes.
Yeah.
Yeah.
So,
Everything is supported.
okay. So at the same time, I can still have another thread running.
Exactly.
So then you mentioned, sorry. So you also mentioned that one application can have multiple renderer processes. How does that kind of...
Well, then you need to care about how you communicate with the main. Like the renderer processes cannot communicate between each other, but you can communicate between the renderer process and the main. And you do hold the logic in the main process, right? So this is how you actually handle it. I know people which are actually using, if you guys want to check it out, it's called OpenFin. They're actually a financial company which use this multi-threading render processing, and they have had a lot of issues. And they actually went inside of Chromium to modify how it handles all the things so it's a little bit more performant. So they have kind of a fork of Chromium and Electron for their own builds because they're a financial office and financial firm, and they offer like tens of different views on the same machine, which is a kind of an overkill.
Hi. Thank you for your talk. I have a question related with what Microsoft announced like yesterday, I believe, about an idea to include progressive web apps into a Windows marketplace. And it is not the first time that it seems that there is an idea in the web world that eventually everything or almost everything should be available natively on the web platform. What is your viewpoint on that from the Electron perspective?
So the thing with progressive web apps, I actually know some teams which are working on it before it was announced, and they have some issues in terms of they don't have full support as Electron has to the system. You need to be dependent on the service packs releases that we are doing. For example, right now Windows 10 is on already RS4 or going to be on RS4, which is like Red Zone 4. We had like 1, 2, 3, and 4. Well, it's always good to have a multitude of things from where to pick and see exactly which one works for you. This is my own thing. Like in Skype, we actually have also a UWP client, which we offer on the Windows 10 RS1 Plus platform. And it's the way to go for Windows 10. As I was discussing, Electron is not a standard. It's a framework and a runtime, but it's not a standard that the big companies will say, yeah, go and build on Electron. Although we have over 400 apps listed on the Electron page. So this is kind of my take on the progressive web apps. There are nice things to have. If anyone wants to try them out and let us know what you think about them.
Yeah, I read an opinion once that yeah, right now not everything is possible with the progressive web apps, obviously, but eventually things like Electron are like just a polyfills until these are available natively in the web platform. So
Sure. That's for sure that will happen. And if you know, Google also had something like Google Web Apps. Not exactly what it was called exactly, like the correct name, but they were trying to do something.
Chrome apps, I believe.
Chrome App, something like that, yeah. But it was like still relying on the Chrome infrastructure, right?
Thank you.
Thank you.
No more questions? Thank you very much for this presentation.
Thank you.